Hey, it's me, Lady Ada, back at my electronics desk. Today I'm working on the next version of the Minty Boost, the Minty Boost Plus. And one of the things I'm trying to fix is making iPhone 3G and 3GS charging work, something that isn't working very well with the Minty Boost. And so to do that, I'm actually going to reverse engineer this Toon Juice from Griffin. And to do that, I'm going to use my awesome new hot air rework station, that Hacko 851. So we'll go through all the steps of me disassembling this, measuring resistors, etc. The iPod charges over USB, and every USB cable has 4 wires. The first one is V USB, and this is almost always equal to 5 volts, and then there's one ground wire, and then there's D- and D+. And for iPhones and iPods, they actually use these data lines in sort of non-standard ways, not to transfer data, but they actually put resistances on it, and that signals to the iPod or iPhone what it's connected to. So, for example, if you're connected to a wall plug, and there's a little USB cable, like the little plugs that you get from a iPhone or iPod when you buy it. D plus is equal to about 2.0 volts, and D minus is equal to about 2.8 volts. And when this occurs, the current is equal to about 1 ampere. So let's verify that. I've built this Minty Boost Plus using those resistors, and I'm going to use my power supply to measure how much current is being drawn. I'm going to turn on the Minty Boost Plus, and you can see it's drawing more than 1 amp. It's only doing more than 1 because of the boost converter. There's a little bit of loss, about 10 or 20%. But basically this is now drawing 1 amp because it thinks it's plugged into the wall. And the wall adapters can supply 1 amp, which means this can charge in like 2 or 3 hours, a very quick charge. Now this is a Griffin Toon Juice, and this is a portable charger, so you see it has an iPod connector, and you put in AAA batteries 4 in a row here, and this converts that voltage to 5 volts and charges your iPod or iPhone. And there's absolutely no way you can get 1 amp out of a AAA battery. They actually just don't have the ability to supply an amp, which means something else is going on in here. It's got a different resistor signal to tell the iPhone or iPod, don't draw 1 amp, draw less, maybe half an amp. So what we're going to do is first verify that, and then we're going to reverse engineer what those resistors are. So now I have the Toon Juice connected up to the power supply, charging this, and you see it's drawing only about half an amp, not a full amp. There's actually, there's the extra 10% because of the inefficiencies of the converter. But it's definitely drawing half as much, which is what we'd expect because, again, there's no way to draw an amp out of a AAA battery, but you can draw about half an amp. That's about the limit of what a AAA can provide. These orange and yellow wires here go to the USB data line, and underneath this spring, if you can see, there's a cluster of 4 very small resistors. These resistors have no labeling on them. They're just black. They're about 1 millimeter by half a millimeter, so they're very small. And remember, you can't measure resistance while it's in circuit, so to get a precise measurement of these resistors, I'm going to have to remove them from the circuit board. Because the resistors are so small and so delicate, using a normal soldering iron, even a really good one like the one I have, may damage the resistors, and I want to be able to take them off the board without destroying them. So I'm going to use a more delicate tool, which is a SMD rework station. This is a hot air station. There's a tube through which the hot air goes, and you basically have a soldering iron type arrangement, except it's a whole nozzle, and the hot air gets blown out here, and you can adjust the air and heat temperature. It's a pretty simple machine. Then what you do is you slowly bathe the part you want to remove in hot air to heat it up until the solder melts, but you're not actually touching it, which means that you can then quickly lift off the part without worrying about pushing it or crushing it with the tip of a soldering iron. So now I'm using the hot air, and I'm slowly blowing the hot air over the parts until I see, say, R24 down here melt, and then I'll try to gently pick it up with my fine tweezers. Almost there. Okay. There we go. Now I'm measuring the first of the resistors that I managed to hot air rework off. And this one is 49.5 kilo ohms. So now I just have to repeat this 3 more times, and then I can basically create my map of what resistances I want to try out. Okay, after a bunch of hot air reworking, I removed all 4 resistors and measured them. Now it's time to actually test whether those resistor values, as opposed to the ones from the AC adapter, make a difference in the charge current. So we've got our Victim iPhone right here, and I've also got a breadboard, and I just wired up a USB-A jack to my desktop power supply and put in a resistor string here so I can see the current coming out of the power supply. Okay, we're going to start with the AC resistor setup. So I've got everything wired up and plugged in. And let's charge this iPhone. Okay, as you can see, it's drawing about 650, 700 milliamps. We'll unplug it. Now we're going to switch over to the resistors found in the battery charger. So I'm going to change these resistors. And now try plugging in again. This time you'll note it's drawing exactly 500 milliamps. Okay, so our project is complete and successful. We've determined that iPhones not only use the data lines to communicate that there's a charger attached instead of a computer, but the resistances and voltages on the data lines make a difference on how fast it charges. Now, if you're trying to build a quick charger, say from an AC adapter or a car where you have tons of power, you should set it to 2.8 volts and 2 volts. That way you'll get the fastest charge, and this will get up and running really quickly. On the other hand, if you're charging from AA or AAA batteries, or even a solar panel, something that can't supply near infinite amount of current, you should dial it down by setting the data lines to 2.0 volts each, and that'll make sure that it never draws more than 500 milliamps.